AP Review. This is 2017 BC for response 2. It is a polar question, and you can use a calculator. So, the figure above shows the polar curves r equals f of theta, which is 1 plus sine theta cosine 2 theta, and r equals g of theta, which is 2 cosine theta, for values between 0 and pi over 2, meaning just quadrant 1. This is my terrible rendition of the graph. Let r be the region in the first quadrant bounded by f of theta. So f of theta is this curve, right? And the x-axis. And let S be the region in the first quadrant bounded by the f of theta curve, the g of theta curve, and the x-axis, right? Find the area of R. Cool. So, since we're using 0 to pi over 2, right, this is really testing just do you understand how to integrate polar curves, right? So I want the area of R, right, which doesn't involve G at all, right? So what I'm going to do for A is the area inside a polar curve is 1/2 the integral from the starting theta to the ending theta of r squared. So in part A, I want 1/2 the integral from starting theta, which is 0, to ending theta, which is pi over 2, of my r, which because I'm only using this one is f of theta quantity squared, right? D theta. I'm going to use the f of theta notation because they called it f of theta. I can always use their notation, and that makes my life a lot easier. Now, I already put both of them in my calculator, right? I'm in polar mode, and I put f of theta in as y1 and r1, and g of theta in as r2. So I quit out of this, right? I'm going to hit math 9, right? And I wanted a 0.5. I forgot it, so I second insert and put a 0.5, right? I go to vars, I go to y-vars, I pick polar and r1, quantity squared, right, with respect to theta from 0 to pi over 2, right? When you do this, double check that you remembered the 0.5, double check that you remembered to square the r, because those are the really common mistakes that we forget, and then I hit enter. And I get a 0.648, which is really all the AP wants from me, right? So the AP wants this, and they want to see the 0.648, and that's it. Part B. The ray, theta equals k, where k is somewhere in the first quadrant between 0 and pi over 2 exclusive, divides S into two regions of equal area, right? But do not solve an equation involving one or more integrals to find the value of k. So somewhere in here, there's some like mystery line here, where theta is k, that makes this half of S equal to this half. There's a couple different ways to do this. Me personally, I always like using the this half has to equal this half. The AP often likes to use the pick a half and say that this half has to equal a half of the entire whole. That's up to you. I personally like to say the first half equals the second half, but any number of answers would be fine. So this first half, right, whenever you want to find the area of polar curves that's between two curves, it's that same 1/2 r squared formula, except it's 1/2 big R squared minus 1/2 little r squared, and you can yank the 1/2 out. So the area of the first half, what I'm going to call the first half, right, should be 1/2 the integral from 0 to whatever k is, because that's the theta that we're looking for in the middle, of big R squared. The big R here is the g of theta quantity squared, right, minus little r squared, which is that f of theta quantity squared, right? Sorry, I missed a parenthesis, with respect to theta. And that should equal the second half, because they're actual halves, right? So they should be the same. The second half should be the exact same integral I just wrote, right? But it should be from k to pi over 2, right? And it's still this thing squared minus this thing quantity squared with respect to theta. Now that's the way I opt to do it. I do that every single time I see one of these problems. The other way that you can do this, and the AP is often a fan of doing this, is to say that if you integrate from 0 to k, it should be 1/2 of what would happen if you did the same thing but integrated from 0 to pi over 2. So the other way that you might see this answer is you might see a 1/2 the integral from 0 to k of g of theta quantity squared minus f of theta quantity squared d theta, right? Because this would be the first half, right? Equals 1/2 of the value if you did the whole thing from 0 to pi over 2 of that same integrand that I'm going to be kind of lazy and not write again. This same integrand right here, d theta, right? So the g of theta squared minus the f squared, but I'm going to be lazy because I ran out of room on my board. I personally like this first half equals the second half because I always feel like someone's going to forget this half when they're writing it because the half of a half can make your brain go all crazy and befuddled. Okay, so part C, and they didn't ask me to solve for K or anything, they just wanted me to set them up. Part C, for each theta, inclusively between theta is 0 and pi over 2, let W of theta be the distance between the points on the polar curves f of theta, comma theta, and g of theta, comma theta. Write an expression for W of theta. Find WA, the average value of W theta over the interval. So the thing is that when we look at this part C, distance in polar is in a lot of ways a whole lot easier because if you're talking about points on the same, in fact, we'll use this little K line. If you're talking about here, g of this theta represents this entire radius to the origin, and f of this theta represents this distance to the origin. So if you want this value, this w of theta is really just the outer curve, g of theta, which is the larger radius, minus this smaller radius, which would be f of theta. So this is what they want for your w of theta, right? So that's w of theta, and that's part C, right? So they then ask you to write an expression for the average value of that over the interval, and then, write an expression for this and then find the average value. So average value of any function ever always follows the same rule. Integrate the function and divide by the width of the interval. So WA is going to be the integral of this function, right? The integral of the thing I called W, so it'll be the integral of W of theta d theta from 0 to pi over 2, and then divided by a pi over 2 minus 0, right? And you can clean that up if you want. I mean, it's entirely up to you. You're going to be typing it in the calculator anyway. So once you do that, they really just want you to type it and get the value. Now, when you put this in your calculator, me personally, 1 divided by pi over 2, I'm probably going to put in a 2 over pi, function integrate. That's not how that's spelled. Okay. And then this is my my R2 minus my R1, right? That's what I stored them in my calculator as. So I'm going to function integrate R2 minus R1 with respect to theta from 0 to pi over 2. And when I type it in, I should get my answer. So you could also have typed all this in and then just divided by pi over 2 if that makes you feel more comfortable. So I'm going to do 2 divided by pi. So I do 2 divided by pi, and then I'm going to do math 9. I'll show you what this looks like in a sec. I go to vars, I go to my y vars and pick polar. I want R2 because I'm doing the g minus the f, minus vars over to y vars down to polar, pick R1, comma, with respect to theta from 0 to pi over 2. So it looks like that, right? And then I'm going to hit enter, and I hopefully end up getting a right answer. I get 0.485, which is exactly what I want to get. So 0.485. So the AP is only giving you credit for this. Like, they want this relationship. They want this, and since they told you to call it W, you can call it W in your integrand. Or you can write your integrand as the two functions separately, but make sure that you explicitly write this formula because they asked for it, and then make sure you write the integral expression you'd need and go from there. Lastly, part D, using the information from part C, find the value for which W of theta equals W average, W sub A, is the function W of theta increasing or decreasing at this value? Good times. Okay, so the first thing I'm going to do, right, so I'm going to take that answer from C, which was the 0.45 blah, 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 and I'm going to store that because I already have it in my calculator. I'm just going to go ahead and store it as A. So in my calculator, I'm going to hit stow alpha A, right? Okay, so what I want is I want to know when does, essentially, so I'm going to go back to my R1 and R2, right? If I want to make R3, so what I want to do is I want to make R3, right, in my calculator, equal to my W of theta, and in order to do that, I'm going to have to do my G of theta, which was R2, G of theta, R2, minus F of theta, which was R1, right? So what I'm going to do is I'm going to go to vars, I'm going to go over to polar, I'm going to pick R2 minus vars over to polar, R1, right? And then I'm going to go ahead and turn off R1 and R2, and a cool thing's going to happen because what I'm going to do is I'm going to make R4 equal to alpha A. So now R4 is a constant function. So now what's going to happen is if I graph these, I'm going to find a point of intersection. So I made my R4 equal to this constant A, right? And then I'm able to, we'll see if you can actually second calc intersect in polar. You might not be able to. All right, so let's see if you can second calc intersect in polar. You can't. Intriguing. They're monsters. So you can't second calc integrate in polar. Because that's lame. That's super sad. So instead, I'm now going to have to do something slightly clever. I'm going to switch modes. I'm going to go to function mode. And in my y1, I'm going to put g minus f, but I'm going to do it in terms of x. So I'm going to put my g minus my f, which would be 2 cosine theta minus the quantity 1 plus sine theta cosine of 2 theta. And in my y2, I'm going to put the thing I called a, because these guys will let me second calc intersect. So it's not awesome when I make a mistake in front of you on a video, but I think it's an important lesson to learn that sometimes you go to try and do something and it doesn't pan out the way you want, and that stinks, but it happens to all of us, and you just have to find a way around it, right? So I'm going to type all this stuff in. Now notice these thetas aren't thetas when I type them in now. They're going to be x's, and that's fine. But again, I'm just working around the limitations of what my calculator has for me. And sometimes we have to do that in life, right? All right, so now my calculator conveniently has what I want. And now when I graph, now I can second calc intersect, right? Again, the AP doesn't care how you get that answer. They just expect you to get it. So the trick here is that I have to graph it in function mode, right? So I'm going to do second calc, and I pick 5, which is intersect. And then they're only intersecting once, so I'm just going to hit enter 3 times, and it's going to hit the right spot. Now remember, the x I get here is actually my theta, because I'm in function mode instead of polar mode. So if we come back up here for a sec. Oh, I also didn't delete the stuff that was in my polar mode because I'm not entirely sure I'm not going to have to go back to that, right? So I just want to point that out there that you don't know that you're not going to have to go back. So sure enough, I got an intersection, right? So I got that these guys intersect. When I found this, they intersect. So WA equals that 0.485 at theta is approximately 0.51768,795, which means that I'm going to give the answer on my AP of 0.517 or 0.518, depending if you run a truncate. Now that's fine, but they then ask me to use that information, right? They then say, using the information from that part, is the function increasing or decreasing at that time? So I'm going to go ahead and quit out of that for a sec. If I hit X, right now my X is stored, so I quit out and I hit X. I'm going to store that. I'm not going to use A because I already used A. So I'm going to store that as B. So I stored this as B. So essentially what they want me to find, if they want to know whether W is increasing or decreasing, they want to know what W prime is doing at this point. Well, because I'm already in function mode, right? So remember that I stored W of theta in as my Y1, right? That was in my Y1. So what I want, in order to know if W is increasing or decreasing, is I want W prime evaluated at this B that I just found. Well, I can totally make my calculator do that, right? I can do n derived of the thing I called Y1 with respect to X, because X is my theta in this situation, at B. And that is going to give me a value for this, right? So I can find W prime at that value. So if I do math 8, right, I go to vars, I go over to y-vars function and y-vars, and I pick Y1 with respect to X at the thing that I totally just stored as B. And I'm going to get negative 0.581 or 82, right? So since W of that 0.517 ... is negative, right? Right? It's less than 0, so W is decreasing, right? Because if W prime, sorry, I'm going to prime there. If W prime is negative, then W is decreasing, right? So W is decreasing at theta is whatever that point value is, right? So that's the deal. Again, sometimes you're going to be midway through a polar problem and have to switch to function mode, which was crazy, but you do what you got to do.